Hi everyone. Today I have chosen a problem from leetcode called single number. The statement is something like this. Given a non-empty array of integers, every element appears twice except for one, and we are supposed to find that single element. I'm going to be taking this following example to solve the problem using multiple approaches. One observation I have made here is that the size of the array is always odd. Okay, let's now begin with brute force. Okay, let's think about how we would solve this problem first, and then we'll try to convert it to computer logic. Okay, so first I have the element 1 here. I will try to find 1 in the remaining array. Okay, so 1 and 1. I have formed a pair, so I will now remove that pair from the array. Okay, now 3. I try to find 3 in the remaining array. Okay, I found a 3, so I'll remove that 3 and the other 3. So that pair is removed now. So 7. I'll try to search the remaining array now for 7. Okay, I found a 7 and a 7. Okay, the single element which is now left in the array is 2, and that is the number which does not form a pair. Okay, now you might ask, why is the time complexity n square and the space complexity O of n? Okay, let me try to explain. How would you solve this using code? I'm going to take in a boolean array of the same size as the array, and then I'm going to initialize all of them to false. Now I'll take the first element. Since I have considered this element, I'm going to mark that element as true. Okay, now I will try to find 1 in the remaining array. Okay, I found 1, so I'll mark this also as true. Now I'll start with the second element. Since it is false, I will mark it as true. We'll try to find 3 in the remaining array. 3, okay, 3 is found, so mark that as well as true. Now I was supposed to consider the element 1, but since it has been marked as true, I could skip that element and go for the next element. Okay, now since 7 is marked as false, I'm going to mark it as true, and I will try to find 7 in the remaining part of the array. Okay, 7 is found, so mark this as true. Now, okay, I should consider 2. 2 is marked as false. Okay, now I'll try to find 2 in the remaining part of the array. Okay, I did not find 2. Now that implies that 2 is the element which does not form the pair. So that will be our answer. So space complexity will be O of n for this extra boolean array. Now time complexity would be n square, because once I consider an element in the array, I have to search the remaining part of the array in order to find that element, and this would account for a time complexity of O of n square. Okay, but can we improve it somehow? Yes. If you look at the time complexity here, O of n log n, this time complexity seems familiar. Okay, it should be sorting, right? So why should we sort it here? Okay, let me take the same example and try to sort it. Okay, so sorted array would be 1, 1, 2, 3, 3, 7 and 7. Okay, now does this make our problem easier? Yes, it does, because now all I have to do is compare adjacent elements. Okay, so 1 and 1 form a pair, so I can move on to the next pair. So 2 and 3 do not form a pair, so now I know 2 is the answer, because if 2 had another element, if there was another copy of 2 in the array, then it would have formed a pair, but since there is no 2 here and we already sorted the array, so this means that 2 is that element which we have to return. Space complexity is of 1 because we do not use any extra array. Okay, but can we improve this even more? Yes, we can. Okay, I'm going to take the same example again. Now, uh, if we take the first approach, we see that for every element, we are trying to search the remaining part of the array to find the same element again. But this is going to take off and time. Maybe I can try to reduce the lookup time. Now, if I'm trying to reduce the lookup time, the best option is to always go for a hash table. Let me call that as HT. This is going to be our input array. This is going to be our hash table. Okay, so how can I work this? How can I work with this? Okay, so I'm going to take the first element. I'm going to check the hash table. Is one already there? Okay, one is not there, so I will add that to the hash table. Now I'm going to go to the next element 3. Is 3 there in the hash table? No, it's not. So I'm going to insert that into the hash table. Is 1 there in the hash table? Oh yes, it is. So that means I have now formed a pair of 1s. So what I can do is I can remove this 1 from the hash table. Okay, done. Now we have to go for the next element, which is 7. 7 is not in the hash table, so I will insert that to the hash table. 7. Now 2. Okay, 2 is not in the hash table. I will insert that to the hash table. Next now element is 3. 3 is already there in the hash table. It means I have now formed a pair of 3s. I can remove 3 from the hash table. So 7, 2. Now we go for the last element 7. Okay, 7 is already there in the hash table. I have formed a pair of 7s. We'll remove 7 from the hash table. I have traversed all the elements of the input. Now, the element which remains in the hash table will be our output, because I was not able to form a pair of 2s. If I was able to form a pair of 2s, then 2 would have been removed from the hash table. So this is another approach. But can we improve it even further without using any extra space? Let's see. Now this is a really interesting approach where time complexity is of n and space complexity is of 1. Let's see how to go about this. Here we'll be using something called we'll be using bitwise XOR. Let me tell you how. If I take an element x, x is a bit, which has values either 0 or 1. Now if I take x XOR 0, I will always get x. You can see that here. Let's say x is 0. So 0 XOR 0 will always give me 0. 1 XOR 0 will always give me 1. So this condition is satisfied. Now this might give you a hint. And the hint is that if I XOR two numbers which are equal, then I will always get 0. For example, if I consider 3 XOR 3, it basically means 0 1 1 XOR 1 1, right? If I take 1 XOR 1, which is 0, 1 XOR 1, which is 0. So a number XORed with itself, bitwise XORed with itself, will always give 0. Now using this, how can we solve our question? So we already know that we have pairs of different elements. So what if I try to find the bitwise XOR of all the elements in the array? Okay, let's take our input array example. right? Now what if I perform XOR on all the elements like this? Right? Okay, in order to make this easier, I will rearrange these elements. So 1, I could do 1 XOR 1, right? I'm just pairing up these different elements, XOR that along with okay, we have a 2 which does not form a pair. Now I'll consider 3 XOR 3, right? And then XOR this with a pair of 7s. Yeah, okay, we have considered all the elements. We have 2, 2, 4, 6, 7. Okay, 7 elements are already considered. I already told you that a number XORed with itself will give you 0. So we have the first pair here will form 0, right? We'll come back to 2 later. 3 XORed with 3 will give you 0. 7 XORed with 7 will give you 0, right? And we're left with the element 2 here. Now let me XOR all of these. Okay, I also told you here that any element XORed, okay, I forgot to write the other condition, X XORed with itself will always give you 0. Okay, these are the 2 important conditions we have used here. Okay, so if we XOR all the zeros, okay, let me consider this pair first, right? 0 XORed with itself, any number XORed with itself will give you a 0. So we got a 0 here. Now I also told you that a number XORed with 0 would give you the number itself, so 2. Now finally we have to do 2 XOR 0. Now a number XORed with 0 according to the first condition is the number itself, so 2. Now this is our final answer. To perform a bitwise XOR of all the elements in the array, all the elements which will form a pair will cancel them out to 0, and finally you are left out with the number which was not able to form a pair, which is 2. Now since we have come up with an optimal approach, I will try to write a Java code for that. Okay, let's say we have a function. We'll call that function. Okay, the function is first of all going to return an integer. We'll call that function single number. We have an integer array called nums. Okay, so first I'm going to take in an integer ans and set that to 0. Okay, now I'll write a for loop to go through each and every element. So int I equals 0, I less than nums dot length I plus plus. Okay, so inside the for loop I will take answer and I will set it to the XOR of ans and nums of I. Now I took ans as 0 because if I XOR any number with the element, I'm going to get the element itself. So in the first iteration, an ans is 0, ans will be set to the first element of the array. Now I keep doing this. After I go through all the elements in the array, I finally have the answer. I simply return the answer. So this was how I was able to solve this problem using multiple approaches. I hope you guys understood this. Thank you.